Quick tips on air conditioning. What we're going to do with this one, we'll show you a little quick trick here. Little Ford Taurus, doing a little air conditioning work, and I've got the vacuum pump hooked up here. And that yellow line goes up into the middle here, which is distributed through this block and then controlled by these two valves. This one's turned off, this one's turned on. What we're going to do is we're going to put a vacuum through this blue line into the car's AC system, and what that's going to do is that's going to pull a vacuum on this whole air conditioning system. Now the reason we do that is not to suck out any old trash or anything like that. Basically, the reason we do a vacuum is because moisture in the air can actually get into the vehicle system when you've got it apart. And I've had it apart putting new parts on it. So what we're going to do is we're going to pull this into a vacuum, and water boils at room temperature under a vacuum, which is about 22 to 24 inches of vacuum. That's going to turn it into a vapor, which will pull it right out of this vacuum pump here, right out of this tip here. So anyway, that's what we're going to do. Now for those of you who don't have the fancy vacuum pump, the easy trick is to take this yellow hose off, and you can buy these gauge systems anywhere. You take this hose off and you hook it into the vacuum line on your car's anything on your car that has a vacuum, and what that does, let it idle, and it'll get 22 to 24 inches of vacuum, and that'll draw that system down into a vacuum. And then before you shut everything off, you close the blue line here, and that will trap the vacuum. Then when you put the charge to it, then it'll go ahead and suck it right on in. Usually about 2 pounds will start a vehicle to blow any cold air. So back on the vacuum, here we have our gauge set up, and basically what we've done is we've got the vacuum itself down just below zero, is right here, and we're about 20 inches of vacuum. And what we've done is we've got the vacuum pump pulled off of it, and this valve is shut from the system up to the block. And what that does is that lets me monitor this vacuum to see if it's leaking. If it leaks up, that means it goes back up to zero. That means I've got a leak in the system. So basically what we're going to do now is we're going to go ahead and do a partial charge on this. So the can's hooked up back on our yellow line here. This is our service line. Now what we do is when we hook this line up, it was free into the atmosphere. So what we do is we burp it out just a little bit, and that's enough. Now we've got full charge all the way up this line, up into this basic valve here. Now what we're going to do is we're going to go ahead and open this up, and that's going to send our charge into our system. Now you can see down inside there, that is liquid refrigerant. Now liquid refrigerant is very cold, as you might have learned. It will freeze your finger solid, and it will cause problems for you, so we don't want to touch that. It does have a little bit of a AC dye and oil in it, which is good, so we don't have to worry about that, and it gives us a little bit more for our system. Alright, so now I've got the coolant bottle put back into place here, and what we're going to do is we're going to actually do a what they call a vacuum lift. And there's all the antifreeze. It looks good. It's still pretty clean, so we're going to reuse it. So here's what we're going to do. This unit right here is called a vacuum lifter, and basically this is just air supply, and it's a blowgun. It just blows through here, and I've got this routed out of the way, and what it does is it creates a low pressure area right here, and that creates a small vacuum which pulls the cooling system into a vacuum. Then this hose right here goes over to our antifreeze. So once it gets to the 15 inches of vacuum, then we can go ahead and open this up, and that'll just go ahead and suck a bunch of antifreeze in there instead of having to pour it in there. And it also helps to eliminate air pockets up inside the cooling system. So we're going to finish that up, and then we'll get back on the charge. Well, we've got everything back together, and you remember we put that initial charge in there. Got all the rest of the components put back together, and now you can see that the air conditioner is in fact cycling. Now what we're looking at here is we're just monitoring the low side pressure is all we're doing right now. So you can see right now it's turned off, and you can hear it turn on, and that means that the compressor is engaged. And what we're looking for is two different factors here. One of them is pressure drop, and then compressor on time. Now the compressor on time has to outweigh the compressor off time. So when it gets down to the end, then we can count 1001, 1002, 1003, something like that, and we basically have to compare the two to make sure that the compressor is being engaged longer than it is when it's not. So the reason why is because when we rev the engine up, it's going to go a lot faster. So watch that gauge. There it's on. Now it's off. That's too much of a gap. So, but here's the next part of the equation. Let's have a look at the dunk temperature. Now, this is what we do. We put this on the middle duct and a medium high to even low. And as you can see, that so you can read that. That's sitting at about 42 degrees. That's a really nice duct temperature. Depending on the ambient temperature of the air around you, you should have at least 40 degrees. Sorry about the beeping. But we need a little cooler duct temperature so that the compressor on time is longer. So what we do is we basically will turn this back on, and we're going to get a little bit more coolant in there. You can see by the sight glass it's going to start bubbling in there. We listen for our on time, make sure that our on time is within a certain spec, and that's one thing I'm looking for, is to see what the spec is on that on time. But basically you want shorter off times. So this just basically is saying that you don't have to have a scale to weigh out your big bottle here. You can put 2 cans or 1.5 or 2 cans or even 3 cans of Freon in it, or refrigerant 134A, but you want to make sure you get it pretty close and you don't overcharge it, because then it will start blowing warm in the dash. So I'm going to stop there, and we'll get back with you a little later on the conditions. Alright, so we've got our on time up to 22 seconds and our off time at about 20 seconds. So we're basically factoring that's between 50 and 55% on time, which is perfect for this. And our duct temperature is registering at a cool 35 degrees. That's plenty for this altitude. We're at 7,600 feet. And one more thing I wanted to give you a quick idea on too. A lot of these systems have fluorescent dye already in them at the factory. So here's what we have, just a little cheap black lights. You can buy these at a hardware store somewhere. And basically, you know, this is a little $10 light. And I'll show you exactly kind of what we suspected and why. Here's our compressor. And basically, if we shine our light over this, you can see the string of fluorescent dye that's coming up through the separation on that. And basically that's what's telling us that this compressor seal has failed. It was a premature failure, and it was probably due to a crack in the case, because these are, most of the time, they are remanufactured. So we've got that done and put a new line in it, and everything seems to be good. We've checked it for the new system here, and it's perfectly fine. We are going to sniff it with our little electronic leak detector sniffer and see where we're at, and we'll go from there. Thanks a lot.